All right, ladies and gentlemen, this is a little added bonus for integer exponents that will truly help you be successful when we're discussing integer exponents. I want to go through each category to make sure that you truly comprehend what you need to know. All right, when I look at this, a to the 0, the 0 power of any number except for 0 equals 1. So anytime you have an exponent as 0, it's automatic that that number is 1. So our examples, 10 to the 0 power, again, is 1. Negative 6 to the 0 power is 1. Those are examples. So anytime you have 0 exponent, it is automatically 1. Let's go to the next one. A to the negative n. I cannot have a negative exponent, so what I'm going to do is I need to change it into a fraction. So any non-zero number raised to a negative power equals 1 divided by that number raised to the opposite positive power. So write the word opposite. Okay, so if you notice 5 to the negative 2, we can't have 5 to the negative 2, so I'm going to do its opposite, and I'm going to say 1 over 5 to the 2, or 1 over 5 squared, and then I'm going to solve. 5 squared means 5 times 5, so it's 25. So 5 to the negative 2 is really 1, and 1 over 25. All right. When you have bases that are the same and you're multiplying, you will end up adding the exponents. To multiply a power with the same base, keep the base, so we're keeping our a's, and add the exponents. All right, so if you look here, here's my example. 3 squared times 3 to the third. Remember, our bases are the same, so I'm just going to add my exponents. So 2 plus 3, all right, and that's 2 plus 3 is 5. So 3 to squared times 3 cubed is really 3 to the 5th power. Now you're going to do a little bit of the opposite when you have a fraction. When my bases are the same, I'm actually going to subtract my exponents. So let's talk about it. To divide powers with the same base, keep the base. So in this case, we're going to keep our a's and subtract the exponents. Okay? So if you look, here's my example. My bases are the same. They're both 4s. And I have 4 to the 8th power over 4 to the 3rd power. I'm going to say 8 minus 3, which is 5. So 4 to the 8th power over 4 to the 3rd power is really 4 to the 5th power. Okay? The next one, when I have an exponent on the inside of the parentheses and an exponent on the outside, I'm actually going to multiply those exponents. To raise a power to a power, keep the base and multiply the exponents. Our example, I have 7 to the 3rd, and then on the outside, I have squared or to the 2nd power. I'm going to multiply 3 times 2. So 3 times 2 is, and this is a typo, it should be 6. Okay, 3 times 2 is 6. So 7 to the 6th power. All right, our last one. A product of powers that have different bases and the same exponent, you can multiply the base and keep the exponents the same. So we're going to multiply the base and keep the exponents the same. So here I'm going to multiply a times b, and then it's going to remain to the n power. Same thing here. My exponents are the same, so I'm just going to say 3 times 2, but keep that 3rd power. 3 times 2 is 6, and I've kept my exponent to the 3rd power. What you're going to do is we're going to end up taping this onto page 19, but I want you to tape it just on the edge so you can flap it up here, okay, and look at the underneath part where we're going to have our examples on page 19.